Hey everyone, welcome back. Today we are going to see about the load test and the regulation of single phase transformer. So transformer load test, a load test which is used to determine which is used to perform in the laboratory to determine the efficiency and regulation of the transformer performance before it is actually used on particular applications. So for getting the value of regulation and efficiency at a different power factor, the different types of loads, that is inductive or capacitive load, should be used. And this is the circuit diagram of a load test on single phase transformer. So here this is a single phase power supply, and the single phase supply which is given into the auto transformer. So with this auto transformer, we can able to vary the output voltage which is given to the transformer. So slowly we can vary the voltage from 0 to maximum value of 230 voltage. So with the help of auto transformer, okay, and this voltmeter and ammeter which is used to measure the primary voltage and primary current, and this wattmeter which is used to measure the primary power, that is nothing but input power. These all are in the input side, and this is the main single phase transformer, and this is the main single phase transformer. So these are the primary side, that is nothing but this is the input side, or it may be called as primary side, and this is the output side, or it may be called as secondary side, or it may be called as load side. Okay, and this voltmeter, ammeter, wattmeter which is used to measure the voltage, current and power, and this voltage is used to measure the secondary voltage, and which is used to measure the secondary current, and which is used to measure the secondary power. And here, so this is nothing but a single phase transformer, and it is connected with the primary and it is connected with the secondary. So under no load condition, under loading conditions, under no load conditions, the sum of there is no flow of current in the secondary coil, so that therefore the secondary current is zero, as well as the secondary power is also, because there is no load. But due to the magnetization component and active component, the primary winding is getting energization and it produces some amount of fluxes. Okay, so for that it drawn some amount of current is nothing but no load current is denoted by I naught. After, when the load is increases from no load to some 10% of load, so therefore there will be a current flow through the secondary winding. There will be a current flow through the secondary winding. So here, because of the current flowing through the secondary winding, it induces some amount of counter EMF, which is some counter flux, which is opposing the main flux, which is produced by the primary winding. So the primary winding fluxes gets decreases. But the main objective to maintain the fluxes constant in the primary side. So in order to increase the fluxes, we have to draw more amount of some much more amount of current in the source by the primary side. So while increasing the load on the secondary side, proportionally the primary drawn more current from the secondary winding in order to compensate the flux produced by the primary winding, which is equalize the counter flux which is produced by the secondary winding. And this is the characteristics. So in this characteristics, it is drawn between the output power of the transformer, and this is one is nothing but a regulation, and another is nothing but an efficiency. So the regulation is how the regulation is determined. So the regulation is determined, a single phase transformer in the percentage, it is based on the formula and regulation, a change in actual output voltage, that is nothing but simply the no load voltage minus lower load voltage divided by no load voltage. So by using this formula, we can able to determine the regulation, and the regulation of the transformer is always proportional to the output power. If the output power is increases, proportionally the regulation is also increases. Okay, so that is the regulation. We have to maintain if the voltage, if the transformer voltage is under normal condition, it will be everything is okay. And the assessment which is the field coil of the DC generator is made up of which one, and the insulating material used between the commutator segment is made up of. Okay, I'll put your answer in the comment section, and these are the few references. Thank you.